Let's think about how viscous our liquids are going to be, because that's obviously going to depend on how much the molecules are sticking to their neighbors, right? Because if we really think through what's happening, we can picture this at a very small scale. So picture you're holding a couple of objects in your hand, and they're not sticking together at all. You try to pour them out of your hand, maybe they're just marbles, and they're just going to roll right out, right? Now picture that you've got something that's sticking to your hand and sticking to each other very well. Maybe you just covered all of those in adhesive. They're not going to pour out of your hand anywhere near as smoothly and as quickly as those marbles did originally. That's kind of what we're talking about here at the molecular scale. By having more stickiness, they're not going to flow and slip past each other so well. So let's just take a quick look at what we're seeing here. Now in this series that we're looking at, as an example, you'll notice that we have 5 molecules chosen, and all of them are carbons and hydrogens alone. And we know that carbon and hydrogen is totally nonpolar. We have no atoms that are there, so we can't have any dipoles, we can't have any ions. The only other possibility for our intermolecular attractions are going to be London forces, or dispersion forces, or London dispersion forces, however you like. All right, so we have our London forces holding this together. We know that that scales with the number of atoms. And here we're going to have, 4, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, total of 20 atoms. Notice what we're doing is we're throwing 3 more atoms in the center each time that we increase the chain. So we have 20, 23, 26, 29, and 32 atoms in each of these cases. So you can kind of picture that as being 20 loops of Velcro and 32 loops of Velcro. Well, more loops of Velcro means more stickiness. And so things are going to flow harder. So my viscosity has gone up. Notice the power on that. Now we're up to negative times 10 to the negative 3. We were at times 10 to the negative 4 originally. Now I do want to point something else out. Actually, 2 something elses. One is that in this example we were talking about London forces, but any intermolecular attraction still participates. We just try to keep a simple system here so we could see the major effect as we went through, increasing any intermolecular force. So if we start with the same molecule and we just are increasing the polarity, well then we're going to see the viscosity go up as well. Now the other thing I wanted to point out, notice we went up by about 0.8, going from there to there. Then going from here to here, we went up by another maybe 1.3 or so. So we're really going up by bigger and bigger units each time. Now that's kind of surprising because these are actually scaling linearly, right? Why should we suddenly have a lot more stickiness? Let me give you a little visualization. I'm cooking pasta. And after it's done cooking, I have a bowl of macaroni, and in a separate bowl I've got my spaghetti. And I've waited for it to cool down a little bit, and now it's starting to stick to its neighboring pasta. Which one is easier for me to pick up? The macaroni or the spaghetti? Obviously the macaroni, right? This has a lot more surface area to stick to its neighbor. Okay, that's true. What if we had gone and we cut up a bunch of the pieces and also put it in there? Well, that would still be easier to pull away from its neighbor. Here's the additional effect that we're not pointing out, though. The long spaghetti strands are starting to tangle around each other, right? You didn't actually put a comb through them as you poured them out of the pot. They're twisted around each other, they're sticking. You've got another strand right in here, another one here. Now you're trying to pull it loose from this bowl of worms, almost literally. You're having the same effect up here. This is more like the macaroni, smaller. This is much longer and more floppy as a result. And so you're going to have both effects. You're going to have more area to stick with, and you're going to have a tangling effect going on too. That's why we see that there's been an even bigger increase in viscosity than we expected. We have both of those effects happening simultaneously.